All right, in this next example here, we've got grid squares to count, so I'm just going to label it U, V, and W. And remember when I did the example for geometric, I had to kind of change the equation because it didn't fit on the page, and I didn't want you upset at me because it wouldn't fit on the page, and so on and so forth. Here we never have this problem because we are going to do it algebraically. So we know what we're doing here. The instructions are right there. So determine the resultant of 3u minus 2v plus 5w. So we set it up in a stacked notation. So I'm going to say that 3u minus 2v plus 5w is equal to, if I add those together, I'm going to end up with a resultant. So I do it in the stack notation. Now with the 3, 2, and 5, what I find helps people remember is that I just put the 3 in the brackets, the 2 in the brackets, and the 5 in the brackets, and people remember then that they have to multiply the vector. So now we need to transfer the 3 vectors that are given into their components. So remember, it's like a road map. If I start at the tail, how do I get to the head of the vector? Well, for u, I went 1, 2, 3, 4 units to the right, so it's on the positive axis. So that's 4i. And because I didn't have to go up or down, it will be 0j. For the second vector v, start at the tail, well, how do I get to the head? I don't move left or right, so that means it's 0i. And now I am heading down. Down means I am going into the negative y values, so that means it would be negative, and this is where common mistakes will be made when you're doing the homework, is that plus minus. That's usually where it starts. So it would be negative 2j. Now v or w, you're thinking, okay, now we're going to have to use an angle. The nice thing with it being on a grid is you don't really need to know the angle, because all I have to do is count squares. So if I want to get from tail to head, I have to go across here. 1, 2, 3, 4 units, and that would be positive. So 4i. And then if I want to get to the head, I've got to come down. Going down means negative values, and it's going to be negative 4j. All right. So we've just taken those 3 vectors and we've written them in algebraic form. So to find the resultant, we have to kind of do the distributive law, and we have to follow the instructions here on the left. So if I want to add up my i's, I would have the 3 times 4. So I'll just use magic pen here. So 3 times 4 is 12, minus, oops, I didn't want to do that, 2 times 0 is 0. So I still have 12 take away 0 is still 12, plus 5 times 4 is 20. So I'm really doing 12 plus 20, so I end up with 22i. So if we would have done this the other day, it would have been 22 squares wide when it went off the page, and that's why I did change that formula. Next, we add up our j's. So using the j's, 3 times 0 is 0, so I don't have to worry about that. So 0 take away, now 2 times negative 2 is negative 4, and I'm taking that away from 0, right? So I have 0 subtract negative 4. So that makes that positive 4, plus 5 times negative 4 is negative 20. So I have 4 plus negative 20, or 4 take away 20. I end up with negative 16j. So you got to be careful with your signs. You're allowed to use a calculator. So with the calculator, you just got to punch in the signs as they appear. Once you have that, you have everything. That's done. We're finished adding and subtracting the vectors. That's it. You're just going to find the magnitude of the resultant, and this is a formula I said you want to have on your formula sheet. And I'll just do x component squared plus y component squared as a reminder. So that means you would have 22 squared plus negative 16 squared. You just got to plug that into the calculator. So if we put that into the calculator, we end up with final answer of 27.2. Finding our angle, theta equals tan inverse of your y over x component. So tan inverse would equal, and I don't put negatives in keep everything positive, and I'll explain why in a second here. 16 over 22. So don't worry about the negative 16. So 16 divided by 22, shift tan. I never worry about the negative because what happens, it messes, the calculator tries to help you out, and you don't want the calculator helping you, believe it or not. So where does that negative come into play? Well, in the therefore statement. So my resultant is 27.2 units in length. And the direction, and we go back to our resultant, it's positive 22. So that means we're going to head east or to the right. And it's negative 16. So then we're going to rotate the 36 degrees either down or south. All right, so we interpret the answer there rather than using the negative 16 in the equation. So everything goes in as positives. Okay, there you go. You just added 3 vectors together. And you can look back in yesterday's homework, or the previous homework, and see how challenging it was to add 3 vectors. What happens if the 3 vectors aren't on a grid? So what happens if we have this situation right here? So we know that vector u is 45 degrees, vector v is pointing that way, and 75 degrees, that's vector w. This is an extremely hard question if you had to do it the other direction here. Oh, sorry, we're not even finding that. We got to change one of the vectors. Let's change this to r. All right, because the question says find vector u given the following vectors. So what's happened here, and I'll go through and show, this is even harder than I thought originally. If you were to do this with yesterday's method with the triangle law, this is extremely a hard process. With using algebra, you're going to find that it's not that difficult. So we know that if we add our vectors, u plus v plus w, we get a resultant. In this question, they're giving us the resultant. We know what the resultant is. We're looking for u. So you just use your grade 9 algebra skills and isolate for u. So I leave u vector here. I'll have the resultant on the other side. And what I do is I just subtract v and I subtract w from both sides. And I find out that the u vector is just r, take away v, take away w. So how does that look? Well, we know that if I take my resultant, I subtract my v vector, subtract my w vector, I will get, or end up with, my u vector. Using algebraic methods, I just got to take each vector and break it into its components. So here it's similar to the one we just did. The only difference is now we're going to use that, our component formula that I told you to make sure is on your cheat sheet. So the resultant vector, we're given the magnitude down here. So 15 cos 45i, okay, and it's to the right and up, so that means it would be plus 15 sine 45j. So I'm just breaking it into its components. The v vector is perfectly vertical, but it's pointing, we would have to go into the negatives. It's going on the negative axis here, so it would be negative 10i plus would be 0j. And finally the w vector, the magnitude is, well, let's change that to a w. It should be a w anyway. So in the example here, make that this one a w. So 25 cos 45, oh, cos 75, sorry, I, and we went to the right and we go up, plus 25 sine 75 j. So that's it. Now it's just calculator work. You've done all the thinking at this point. So you just got to use your calculator and add up your I column, okay, and add up your j column. And remember that we are subtracting this time because we rearranged the formula. So your calculator, you would put 15 plus 45 minus negative 10. So you got to be careful with the signs here. Minus 25 times the 75 cos. The calculators will do this all in one step, and I encourage it. So 14.1 I, and the other one, 15 times 45 sine minus 0 minus 25 times 75 sine gives me negative 13.5 j. So there you go. If you look back at how much work you did yesterday adding using the triangle method, here you just subtracted 3 vectors just like that. So magnitude of u. So the original vector, again, I'm just going to go x squared plus y squared instead of writing out the word component, and you're welcome to do that as well. 14.1 squared plus the negative 13.5 squared. If you were listening, you don't have to worry about the negatives, so you wouldn't need to put that in there. It is going to end up being positive anyway. And we end up with a result for a vector of 19.5 units. Find the angle. And this is the beauty of the algebraic method. It's always the same process. Once you've broken the vectors down into the components, it is the exact same steps. So once you have the process down, you are all set. Again, we don't worry about the negatives. We'll take care of that in the concluding statement. Shift tan, 43.8 degrees. So therefore, the u vector is 19.5 units, and its direction, so again, started off in the positive 14.1, so that means it started heading east, and then negative 13.5, so that means we turn south or down, and the angle goes in between, 43.8. So again, when you compare this to yesterday's or the previous day's work with the triangle method, you are going to find that the algebraic method is far superior and a lot quicker. All right, so there's a handout for you to work on in practicing this skill. If you have any problems, let me know, and we'll get them cleared up prior to the test.